Hello guys, so today we are back again solving a few questions from a type of collection in STL. This time we are going to be solving questions from Deque, or some people even call it Deque, but I will be calling it Deque. And previously we have solved some questions of list, and Deque is very similar to list. All the functions are completely similar. You can push from the front, you can push from the back, you can pop from the front, pop from the back, and place. Everything is same. The only difference between a list and a deck or a DQ is that a list uses a doubly linked list, which means you are not allowed to access elements randomly. So a doubly linked list is implemented like this. You can go two ways with each element. So this is how a doubly linked list is implemented. But in DQ uses dynamic arrays internally. So due to using dynamic arrays, random access becomes possible. So if you have a DQ called D, you can just access any element using its index, which is not possible for list. So we are going to be practicing some questions of DQ today. So I'm skipping the first two questions. They are just use the push and pop functions for these. Very simple, you don't have to worry about this. I will be starting from the third question, although it is still pretty similar. There is no harm in trying out how reverse works with DQ, or if it will be completely same as list or not, because since for vectors there is no inbuilt function, and for list there is an inbuilt function for reversing a list. So let us test out if DQ also allows us to use some inbuilt functions, or we can just sort it or reverse it the same way we can do so with a vector. So I will be starting out with the third question. You can also try it out with me if you want to, and I will go quiet now. Okay, so we have solved this question. We just had to reverse the DQ. So as we can see, if I try to search for a reverse function in DQ, we can see there is no reverse function. And we can similarly check sort as well. There is no sort, so there are no inbuilt functions in this case. Let us try out sorting as well if that works fine with Deque, although it should, because it is using dynamic arrays internally, same as vectors, so still testing it out. Yeah, so this works. Now we can move on to the next question. You can also try it out with me if you want to. Okay guys, so we have solved this fourth question as well. In this we just had to create our own structure of browser history. So what I did for this is, since we are practicing DQ, I just created a DQD and then created three operations. The first is to visit, which basically when you're visiting a URL, then it adds it to the back of this DQ, and then a back function that removes it from the end, a forward which is not allowed, so it wasn't implemented, it is not needed, and one to print the current URL. So after creating these, I checked the input test cases, and it shows that we will be inputting like line by line: visit google.com, then visit openai.com, then back, then visit this, then back, then back. And so what I'm doing for this is I'm using a while loop, and we have a string L, and I'm using getLine to like get the whole line in the string. And if the line is equals to end with all letters capital, as we have seen here, then in that case it breaks the loop. Otherwise, what I am doing is I'm finding the space, the next space, and then I'm finding the URL and the input. And if the input is equals to visit, then I call the visit function and print function of the browser class object that we had created. And otherwise, I just call the back one. And one interesting thing is that if like my DQ is empty and I try to call the back function, in that case it automatically ends the while loop without throwing an error. So I don't exactly understand why that is happening, but there must be a reason to it. Let me ask ChatGPT honestly. So by the way, I'm not even doing like a check here, like if the DQ is empty. So it is automatically doing it somehow. And the weird thing is that the way it is doing it is calling both of these functions completely fine, correctly, and then it is breaking out of the loop. So why that is happening, I don't know. Okay, so basically it is just saying that it is undefined behavior. It could have been any way depending on the compiler. So just do an empty check here and it's fine. I am moving on to the next question right now. I am not doing that. You can do that if you want to, and you can start solving the next question with me as well if you want to. And yeah, we'll stay quiet now. Okay, so we have solved this question as well, the fifth one, sliding window maximum. In this question, what we had to do was, he was given an array of an integer and a window size k, and we had to print the maximum element of each window, every single window, and we had to solve it in O of n using Deque. So I have done exactly that. What I've done for this question is, after taking the input for the vector and the window size, I created a Deque of pair. So what this pair included was the index and the maximum value. So basically, the whatever the previous window was, it is recording its index, recording the index of the maximum element and the maximum value itself. So for the first loop, what we do is we just check if it is empty. If it is empty, in that case we place back the index and the value itself. Otherwise, we just check if the current one is greater, so we pop the previous one and push the current one. After that, we move on with the while loop. So now we are going to be sliding the window one by one, and so we just have to keep this condition in check till end is less than vector dot size. This end in is the ending of the window. Why I have done this is because when you will be sliding the window continuously to the right, you will be getting a new element from the right. So that is the only thing. So we just first check if the previous maximum element, if it is still in the current window or not, using this condition n minus k plus 1 is less than equal to the index of the previous maximum element or not. If it is still in the current window, then we just check if it is greater than the new element that we just got. If it is, then we just push it back in the DQ again, because it is still the greatest element in the next window. Otherwise we just add the new element, and if it is not in the previous one, if the previous greatest element is not in the current window, then we know that the new element is going to be the greatest one. So we just push it, and yeah, that is it. I don't know if this solution is correct or the most efficient. We will just have to check. My head is not in the right place right now, so I'm not able to think properly. Let us ask ChatGPT. Just a second. Okay guys, so we have solved this question now clearly. Although my previous approach was working on the test cases, it would not have worked everywhere, because in it I wasn't keeping the track of like the maximum elements in descending order. That is something that was kind of needed to make it work accurately. So I wasn't doing that, and this turned out to be a difficult question, a good question. These are the type of questions that I have been wanting from ChatGPT on these specific topics. So what we are doing in this solution is we are initially I was taking a Deque where I was storing the index and the maximum element. You don't exactly need it that way, although you can do that, obviously no one will stop you, but you can just directly use the integer or the index. You can say you can just directly use the index of the elements. And what we are doing is, just a second, so let me quickly tell you what we are supposed to do. For example, we have a Deque, name it anything. I'm just going to be using square brackets for now to explain it to you. So what we want to do is, let us take the test case that ChatGPT gave us. So we have an array. So let us take this array. Let me draw this again. Looks kind of shit. So we have this whole array and we are given a window of size 3, so about this much, right? So what we are going to be doing is we are going to be using a Deque, a monotonically decreasing Deque at that. So we will be using it, we will be appending from the right. We will be, since it is a queue, we will be adding from the right. But popping, we will be popping from both sides. I will tell you how, conditionally. So let us take like the first element. It should be monotonically decreasing, right? So we have the first element, which is 1. You just add 1. Then we have the second element, which is 3. Now 3 is greater than 1 and it should be decreasing. So since 3 is greater than 1 and this violates the condition of it being decreased, what you are going to do, you are going to be popping from the back. So from the right you are going to be popping and you will be adding the new element, which is 3. Now we can do the same thing with -1. -1 is decreasing, so we will just add it directly. Now by now we have a window of size 3, so we can check which is the most maximum element in it, which is 3. So let us have result here. We will add 3 in it. Then we will move on to the next position, -3. And from the left we will also check if we are out of bounds by now or not. So if we are out of bounds, for example, this will become the next window. And since the leftmost element is 3 and it is not out of bounds, so it is going to be staying inside. We are not going to be removing it. And this is why we are appending indexes inside of the DQ instead of the element themselves, so that we can check if it is out of bounds or not. And so now we have moved the window one step ahead and we got a new element -3. Now it is still decreasing, so we can add -3 over here as well. Now we can just check the most maximum element in the front, which is still 3, so we will just add 3 in this case. Now we'll move it one step ahead, move the window one step ahead, and now we have the new element 5. Now 5 happens to be greater than -3, so since it will violate the condition of monotonically decreasing, you will just remove -3. Just a second, you will remove -3. Now -1 is again smaller than 5, so we will be removing it as well. 3 again smaller than 5, we will be removing it as well. The only element which will be left in this bino is 5. Now why this works is, for example, once you have reached 5, moving ahead from its leftmost element, or the adjacent left element, you can say, which is -3, until 5 becomes the leftmost element in the sliding window. No element to the left of 5 can be greater than 5 itself, right? So no element to the left of it can be greater than 5, so they can be removed from your DQ. And since we are appending indexes in ascending order, so initially, for example, it was 1, so after that you removed this 1, you added 3, which is 1, the index of the element, and for -1 you just added 2, for -3 you added 3. Then when you reached 5, as you can see, the indexes are increasing. So all of the indexes to the left of 5 are obviously smaller than the index of this element 5, and they can never actually be greater than 5. Obviously, moving ahead, they can not be greater than 5 itself. So if we have a maximum element, and all the elements to the left of it are smaller than it, so doesn't matter how far ahead we move, we know that these elements to the left of this maximum element are never going to be greater than this maximum element. So you don't actually need them, you can just discard them. So that is exactly what is happening in this case. So since we have added 5 now, and now we are going to be checking which is the element in the front that is going to be the greatest element, which is it is 5 in this case. You just add 5. Now you will move the window at 1 position, decreasing. 3 is decreasing, still the front is 5, so we will be adding 5. Now we move on to 6. As we can see, 6 is greater than 3, so we will be removing 3. 6 is greater than 5 as well, we will be removing 5 as well, we will be adding 6. Now the frontmost element in this DQ is currently 6, we will be adding 6. Similarly with 7, it is greater than 6, so we can just remove 6 and add 7, and there you have your final output accordingly. So I hope I was able to explain it well enough. If I was not able to, there are other solutions online that you can check out, obviously. So let me show you my solution now, although not exactly my solution, I just wrote the code, but anyways, just a second. So what I'm doing is, in this solution is, I have the DQ in which we will be pushing the elements and popping them, and we have the vector called result. Now I am running the loop from like the first position to the last position till n, and what I'm going to be doing first is I'm going to be checking if the leftmost element is out of bounds or not. So if while the leftmost element is out of bounds, I'm going to be popping it from the front. Leftmost element is in the front. So, and then the second step is to check if the current element satisfy the monotonically decreasing condition or not. If that condition is violated, which is the current element being greater than the rightmost element in the queue, So in that case, you will be popping from the queue until the condition is satisfied, and then you will be adding the current index. And this last condition is just to check if we have reached minimum window, the required window size or not. Once you have reached it, then you can start adding the elements to the list. So it is just checking for that. So this is the solution. By the way, why you are using a DQ in this case instead of uh, a normal queue is because a DQ allows you to add elements and remove them from both directions. And why you are not using a stack, because in this case, as I have already told you, the elements are in decreasing order, but the indexing is in increasing order. And since we want to check for out of bounds from the left, and we want to check for the monotonically decreasing condition from the right, you will be adding from the right and removing from the left. So implementing this using stack will be difficult, if at all possible. So this was the solution to this question. Very good question. These are the type of questions that I actually want to solve when practicing these different kind of collections in STL. Now we can move on to the next question. You can also try solving it with me if you want to. I will become quiet now. By the way, the learnings that we got from the previous question, the sliding window question, is that a DQ can be a very useful tool for sliding window questions. It can be used to store elements in a decreasing order as well, or an increasing order, similarly for indexes, accordingly what you need. And since we already know, it allows for popping and pushing from both the front and the back, so it becomes very useful in those scenarios if that is a requirement in that case. Although these type of questions, obviously you can't just solve them by understanding a collection itself. You have to really use your brain and understand the patterns and the logic that is to be applied in these questions. So as you practice them more, the more you will be able to understand them, solve them easily, and so that is it. Now we can just move on to the next question, and you can also start solving it along with me. Okay, so we have solved this question as well. Very simple, we just had to do a palindrome check. We have done this question for basically every type of collection we have did, like list, vector, now DQ as well. So simple palindrome check, but obviously since we had to use DQ in this, what I did is after taking the input of S, I created a DQ called DQ. See what I did there? And then I just put all of the characters of the string S in it, and I ran a while loop till the DQ was empty. And if the front and back are equal, or if the front and back characters are same, then in that case palindrome condition is satisfied still by now. So what we can do is we can pop from the back and from the front as well, unless they are empty. So for example, if there is only one character left, if we are popping from the back, then popping from the front can cause undefined behavior. So you just first do an empty check. You can do an empty check for this as well if you want to, it doesn't matter. And if they are not equal, you just simply return false. If you come out of the while loop, you return true. So that is the solution, very simple. Now we can just move on to the next one. You can also try solving it with me if you want to. Okay, so for now I will be skipping the seventh question. ChatGPT is basically asking me to implement DQ using a DQ, so that is a bit dumb, I would say. Although you can make it complex for yourself by like using a vector if you want to simulate it, because it is a dynamic array as well. So you can try creating a DQ using that. I don't want to waste my time on this right now, so I think I will be skipping it. Although I can like do this, I can try using this new string stream. I've never used this before, so but for now I don't think I'm going to. I think I'm just I think instead of implementing the whole thing, I will just practice string stream instead. I've never seen this before. I will try this out. For now, I'm going to be skipping the implementation of string stream most probably, because this video is about Deque, so I will just show you what I've implemented once I've implemented it, because it is just simple, like it's a simple piece of code. You don't have to think about it. You are not learning Deque using it in any sense. So let me just skip ahead. Okay, so I have checked out what string stream is all about. It is basically a way of like splitting this input string, kind of, you can say. So with each space basically, so what it does is you can use these operators. I don't know what they're called, but you can create a string stream of the input string that you got, and using that string stream you can like take each part of the string separated by space and put it in anything that it can be put in. For example, I have a command push underscore front 20. So push underscore front can be assigned to a string, and this integer value can be assigned to a string as well, or an int value as well. So it makes it simple to like divide it kind of in that sense. So we can go ss command to value. Let us see if string works as well. The string value, this should work. Yeah, this works. So you can use this operator to put it in command and value accordingly. I think this is stream extraction operator. This is stream insertion operator. I don't remember exactly. So you can use this string extraction operator in that case. Not big deal, not even important. You can skip this part if you want to. Not part of the actual lesson, you can kind of say. Now we can move on to the 8th question. You can also try solving it with me. I will go quiet now. Okay guys, so I have solved this question as well. I'm really sorry if you can hear kind of a drilling sound in the background. I can't do anything about it. There is some work going on in the neighborhood. But anyways, this question was extremely unclear to me. Uh, ChatGPT kind of just gave a vague statement to me what we have to do in the question, so I did not understand it well enough. I will explain it to you to the best of my capabilities, obviously. So what it says it is we have to print the first non-repeating character in the stream. So if we are given a string of characters, we have to print the first non-repeating character at each insertion. For this, we had to use a DQ and a map. So I did not understand one bit what it was trying to say here. So I went to check the test case, and these test cases are wrong. These made me even more confused. So I asked ChatGPT to explain the question to me. And when it started explaining, then it started making a little bit of sense. So you have a stream of characters. You check each character one by one along with their frequency, and at each position you just print the last non-repeating character, or the first non-repeating character, you can say, not the last, the first non-repeating character. So, and if we have no non-repeating character, then we just print -1. So again, I was really confused what it was trying to say, so I looked a bit to the test cases. So what is happening here is, at each position we are checking if there has been a repeating character or not. Wait a second, I think I need to explain it to you better. Okay, so hopefully you are able to see my screen. I have taken 2 test cases. I will be explaining it to you using these 2 test cases. Let us start with the first one. Let us have a map. First, let me write on top the result. And let us have a map because we have to use a map and a DQ for this, right? So let me create the map, let me create the DQ as well. So what we want to do in this is, at each position we check the character. At each position we check if there has been a non-repeating character by now, and if there has been, then the first character, which is the non-repeating one, is the one that we are going to be printing. So for example, first we have A. So the map becomes A with a frequency of 1, and the DQ becomes A, right? Then we move on, and then again we have A, so map becomes A with a frequency of 2 instead of 1, right? We write it correctly, 2, and the DQ becomes A and A. So what we are going to be doing with the DQ, with each element we are going to be checking if the element in the front of the DQ is a repeating character or not. If it is a repeating character, by just checking the frequency of it in the map. If it is a repeating character, then we just remove it, and we do this for all repeating characters of the DQ with each iteration in the loop. So it might feel like it will become like off and square or something, but it won't, because for each character in the stream that we have, we will be only doing 2 operations on it in the DQ, push and pop. So it will be 2n at max. So we'll be popping like this. So since frequency of A has become 2, we will pop this. Well, let me update the result as well. So before we reach 2, in the first position we have A with a frequency of 1 and DQ is A. So there is only 1 character, no repeating character. So in this case we are going to be updating the result with A, like this, right? So then we are going to be moving on to the next position, which is this A right here, this one. So now the frequency becomes 2 and the DQ becomes A and A. But we are going to be running the loop, checking if to remove all of the repeating characters from the front. So this A will be removed and this A will be removed. Now by this point the DQ is empty. Since the DQ is empty, we are just going to be adding a -1 in the result. Now we will move on to the next position, which is B. So the map would become A and B with a frequency of 1, and DQ will become B. So now DQ has one element B, so we are going to be printing B. Then again next B, the frequency will become 2, and the DQ will become B and B. So now we will start removing characters. This B will be removed since frequency is 2, this B will be removed since frequency is 2. Now the DQ is empty, we will be printing -1. Then we will move on to the last position, which is C. Frequency becomes 1, DQ has 1. Since the frequency is less than equal to 1, we will be adding it to the DQ. There is a condition I forgot to mention. If the frequency is less than equal to 1, only then I am adding it to the DQ. Although I don't know if you have to necessarily do it that way or not, I just do it like that. So since the frequency is less than equal to 1, you just push it in the DQ, which is C. Now the DQ is not empty, you have C in there, so you will be adding it like this. You can also do it opposite way. What you can do is, let me show you my code for a second, just a second. So yeah, in my code you can see that I'm running the while loop before I'm adding the elements in the DQ. You can also run it after it and then start printing accordingly. So you just have to run it after this if condition if necessary. I will explain it to you, explain the code to you in a second. First I'm explaining the algorithm itself. So I think this test case should be clear by now. Now let us move on to the next one. So let me create result, the map and the DQ. So first we move on with A. The map becomes A with a frequency of 1 and the DQ gets updated with A. Since we have added A in there, we check what is the last non-repeating character, which is the frontmost character of the DQ, in this case A, and we print the result A. Next we move on to the next position, which is B. Now the map gets updated, B with a frequency of 1. B will be pushed to the back of the DQ, B. And now again we will check from the front if the first we will try removing the characters if there have been any repeating characters. No, so we will just check what is in the front of the DQ, which is A again, so we will be printing A. And similarly for C, frequency of 1, it will be added to DQ, but the front character is still A, you will be printing A. Again with D, same situation, you have D, the front character is A, you will be printing A. Again with E, frequency becomes 1, you get added to the DQ, and then the frontmost character is A, you will again be printing A. So that is basically the how the algorithm is working. You have to print the first non-repeating character, so you can keep a track of them by adding them to the DQ, the non-repeating characters to the DQ, and removing them accordingly as well. This is quite similar to the first question, not to the first question, the previous question that we did. Not similar, but one can say the application is kind of similar, although that was a sliding window maximum question, quite different, but anyways. I hope the test cases made it clear. Now I will explain the code to you quickly. So what I am doing is I am just creating an unordered map and a DQ, and with each loop what I am doing is, first of all I am adding the new character to the map, increasing the frequency by 1. So, and then I start checking for the DQ, start removing the characters from the front of the DQ if their frequency is greater than 1. So basically they become the repeating characters. So we are basically removing the repeating characters from the front of the queue, right? So you don't have to do the while loop here. Let me explain in just a second. Then after that what I do is I just check if the frequency of the character in the map is less than equal to 1 or not. If it is, only then I'm adding it to the DQ. And Then I move on, I check if the DQ is empty or not. If it is not, we print the front. If it is, we just print -1. Now this while loop condition that I'm doing, I don't have to do this here. I can just shift it after I add characters to the DQ, and I also don't need this if condition. So what will happen now is you will be pushing the character back anyways, but then it will be getting removed from the front. Okay, no, maybe you do need the condition. Let me just clarify in a second. It's better to use that condition, this if condition, although the while loop can be after this, it doesn't matter. But why it can be useful to use this if condition is because, let me show you. Let us assume you have something like A, B, right? So let us try. Let me create a map and DQ. So first you will have A, so the map becomes A with a frequency of 1, and the DQ will become A, so the result will be A, which is in the front of the DQ. Then it will be B, so B will be like this, frequency of 1, B. We start checking for the non-repeating characters from the front, none repeating characters in this case, nothing will be removed. Again, the front is A, so we will be printing A. Next we will have A again, right? We will have A again, so this frequency in the map is going to be updated to 2. Now if we first check the condition that if the frequency is greater than 1 already, in that case we won't be pushing it, right? So if the frequency is greater than 1 and we won't be pushing it, then it works completely fine. You will check for removing the characters, A will be removed and B will be there, so you will be adding B over here, right? But if you don't have the if condition to check if the frequency is less than equal to 1 or not, and you just add the character without checking that condition. So for example, I've added A here, so the loop will be running from the front, checking for repeating characters. This is repeating, A will be removed, B is non-repeating, B will not be removed. So again the answer will be B, but in this case we can see that 1A is still over here, right? This A is still over here and it is in the back, it is not in the front, so it won't be removed. Now the issue with this is when we move on to the next position, which after this A is going to be this B, so this frequency will get updated to 2, this will get removed and this will get removed. Okay, so my bad, you don't actually need that condition. Okay, it actually made it more clear for me as well. So you don't need that condition, you can just do without it, and we can also try running a couple of test cases for it. So let me just try to run the question without the condition. Yeah, so let us see. We'll be running all test cases one by one. 5. By the way, this was a very good question to practice DQ. You should try it yourself as well, and the previous one as well, that was also very good. But so let us run this test case. The output is correct in this case. Next one, 4 times x minus 1 minus 1 minus 1, 5 A, B, C, D, E, 5 times A. Next will be 6 with A, B, C, D. A, B minus 1 CC, correct. Now this fourth test case, I think ChatGPT has made a mistake in this as well. Maybe we should try dry running it, this one, in a second. But let me show you. So my output in this is m minus 1 and then 4 times n, but ChatGPT's output is m minus 1 and n minus 1 p. I don't know how it got to this output, but since I've already made one mistake with the if condition, I should not be too hasty and I should maybe try running it with you guys obviously. So let us try to run this one quickly. Let me just remove these. So yeah, the test case is M N O O P. So map will become M with a frequency of 1. DQ will become M. You will be printing an M here. Then with the next M, the frequency becomes 2. M will be removed, and so this will become -1. Now again the frequency becomes 3, DQ is still empty, this will become -1. Now we will add the next character, which is N. This N, the frequency becomes 1, it gets added to the DQ is not empty, you will be printing N. Then we move on with O, frequency becomes 1, O gets added. But in the front we still have N and it won't be removed since its frequency is still 1, which means it is non-repeating still. So we will again be printing N from the front. Then frequency of O will become 2, but N won't be removed obviously, and so it is still in the front. We will still print N. Similarly with P becoming 1, P will be added, but N is still in front, you will be printing N. And even with the if condition, it is same, completely same. So since you are going from the front, you won't be you will be only be printing N from the front. From my understanding of the question, I think the output should be this, as my solution has given as well. ChatGPT might have made a mistake, and I believe so as well, because the test case that it gave me up here that confused me, these test cases are also wrong, especially the first one. So I trust that it might have made a mistake here. So anyways, we will be ignoring the fourth test case for now. If you think I have misunderstood the question as well, so just comment down below and tell me, because I actually don't know. I'm solving it to the best of my understanding. Oh yeah, I could not show you the test case above. So ChatGPT had already given me wrong test cases up here, these ones, especially this one and this one. So since these test cases were wrong, I was really confused before asking ChatGPT to explain the problem to me. So I believe it gave me another wrong test case with the fourth one as well. It is possible. Again, if you think I have made a mistake or I have misunderstood the question, please comment down below and let me know. I am solving it to the best of my knowledge or to the best of my understanding of the question. Now we can move on to the next test case. We can try it out as well. 1 Z, it is still Z. 0, we will keep blank anyways. Let us see with 4. A, capital A, small a, -1, capital A, small a, -1. Test case 8. 6, 1, 2, 1, 3, 2, 4. 1, 1, 2, 2, 3, 3, 1, 1, 2, 2, 3, 3, correct. This one we have already tested, the first one. This last one will also work since we have done 4 times X. That worked correctly, so the code works fine. And I think it is a decent code. I have not looked at ChatGPT's code. I think it should be... It is similar. It is completely same as mine. Yeah. The only difference is he's continuously taking in the input and updating it accordingly. I just first take the input, then I iterate the vector. So it is same. The overall logic is completely same. So yeah. Anyways, very good question in my opinion. Very good question to practice DQ. This and the previous question as well. Not the previous question, the 5th sliding window one. Palindrome check and 7th question were quite easy. The sliding window question, now that was difficult. And this question was also, although it wasn't necessarily that difficult, just Understanding it was difficult because ChatGPT made a lot of mistakes here. Obviously, it can't be perfect, which is why I, in general, try to search for questions outside of ChatGPT, but it is not easy to get questions for specific topics like Deque and stuff. Good questions, so this is more of an easy way. Now we can move on to the next question. You can also try it out with me if you want to. This ninth question, rotating a DQ. I will become quiet now. Okay, so the next question is the general rotating the collection. So we have done this with every kind of collection that we have found, vector, list, now DQ as well. So again the same code that we have used previously for the list. Since the operations are same, you just first do k, which is the step k equals to k modulus dq dot size, since you don't want to continuously keep it rotating. And then what you do, you run a loop k times, then you just pop an element from the back and just push it to the front of the DQ, then you just print the elements. Works completely fine. Now we can just move on to the next question. You can also try it out with me if you want to. Okay, so we have solved this question as well. This was kind of vague. So we had to create a priority task scheduler for this using a DQ. And ChatGPT just told us we can make any that we want to. So that again is a bit vague because it is what it is. But anyways, what I'm doing for this one is I could have done it two ways. I could have like ordered the element based on their priority. Whenever we enter a new element, we can just place it in the right position according to its priority. But then the solution would have become an O of n square solution using the DQ as well, because we can only push in front from the back, and inserting in between is not an O of 1, is not an of constant time solution, so we could not have inserted in between either. I think inserting in between a list would be an O1 operation because it is a doubly linked list, so that should work. But with a DQ it does not work since it is a dynamic array. At least I think so. Let me ask ChatGPT first. So in the middle, inserting in the middle is an O of n solution. We know that already. So we could not have used insert. Obviously, it would have been an O of n square solution anyway with the DQ. But if we were using a list, by the way, let me just tell you it. If we were using a list, it would still be an O of n square solution because we will have had to find the next element with the highest priority or the lowest priority in front of which we can add the current one with higher priority. So we again would have been an O of n square solution. But anyways, what I did for this one is since I could have created a priority task scheduler of my own in any way I wanted. So what I did is each time when we are inserting, if the priority is greater than the frontmost priority or the frontmost priority of the frontmost task, then in that case I'm going to be adding it to the front. Otherwise I would just add it to the back. And if whenever we execute using exec, the task in the front is going to be getting executed, so we can just move it to the back, the very end, and then we can just check what the final DQ looks like. I think he is just printing in this case. It will be printing in the same way. First it would be T2, then T4 in the front, so it would be T4, then T1 and T3. Same output that we get. I'm just printing the queue at the end. You can just print each task one by one like this right over here instead of, and then you can just push it to the back, print it, pop it, push it to the back. That is basically what I did with this one. Let me ask ChatGPT if this is a good enough priority task scheduler. Obviously it isn't, we all know that, but let us see. Okay, so instead, what ChatGPT thinks we should do is, for execution, we should always find the highest priority task, the next highest priority task in the queue, and then execute it, and then just push it out or pop it out, you can say. You can do that, obviously, nothing wrong with that, but okay. We can do it that way as well. Maybe I should do it, why not? If Deque is not empty. What ChatGPT is doing in this case, it is just inserting to the back, and each time it is running an open search operation to search for the highest priority element and then erase it. I mean, this question feels more of a waste of time more than anything for me. So maybe I should just skip it. I don't exactly need to do this one. Actually, I think I'm just going to skip this one and move on to the next question. You can also try it out with me if you want to. If you have not created a priority task scheduler yet, you can create it the way ChatGPT did. I just did it this way because I found it easier. But anyways, let us move on to the next question. You can also try it out with me if you want to. Okay, so we have solved this question as well. It was quite simple. We just had to implement a stack using two DQs. It is basically the same question as implementing a stack using two queues. So, I mean, it doesn't make sense to implement a stack using two DQs since we can already push and pop from both sides. So you can just implement a stack directly using DQ. But anyways, ChatGPT said that in interviews or stuff, sometimes you can be asked to do that. But anyways, what I did, I just simply created two DQs, and whenever I'm pushing, so what happens is, let me show you using a test case. So let us say we want to push 1, 2, 3 and 4. So we have Q1 and Q2, right? And let us say that Q1 is the one that we usually pop from, or that will be containing the elements usually. So if you are popping from the front, you should be pushing from the front as well. Otherwise it's not a stack. Stack is a last in first out. So that is the way we want to do it. Obviously in DQ we can do this, but let us assume we can't. So we can only push from the back. So how do we do that? So for example, first I'm inserting one. One is in Q1 already. So when I insert 2 should not go over here. 2 should go here, right? But we are not allowed to add from the front or push from the front right now. So what we can do in that case is that we can just push it in front in Q2 first. So since it is pushed in Q2 like this, then we can pop 1 from Q1, push it to the front, it becomes 2, 1. So exactly the way we wanted it to be, and it will be removed from Q1 obviously. Now we can reassign to each other. Basically what we can do is we can swap Q1 with Q2 like this. So once you have swapped these two, what will happen is Q2 will become empty, Q1 will become 2, 1. Similarly, if we want to add 3, we can't add 3 over here. We have to add 3 to Q2 first. Then we can pop from the front of Q1, add it to Q2, again pop, add it to Q1, and then we reassign or swap the two. So it becomes like this. Q2 will become empty, Q1 will become 3 to 1, and similarly for the last case, it will become 4, 3 to 1 like this, and that is all there is to it. Once if you have to like pop an element, you will be popping from the front. So pop from right over here, again pop, pop and pop. It will be a LIFO structure. So why this works is obviously in a stack, when you are adding 1, then you will be adding 2, then you will be adding 3, then you will be adding 4, right? So you will be popping 4, then 3, then 2, then 1. So it will become 4, 3, 2, 1, the output. Similarly here, if you pop 4, 3, 2, 1, same. So that is basically how it works. The push function works like this. So what it is doing, it is first pushing the new element to Q2, copying the whole of the second queue starting from the front to Q2, and then just swapping between the two. You can also use the swap function over here. You can just write like swap Q1 comma Q2 instead of this whole thing. Obviously I'm not doing it because then it will swap them back again, but anyways. Then for pop function, you just check if it is empty or not. If it is not, you just pop from the front. Similarly with top, you just print whatever is in the front, and that is it. Then you can just put in the commands and check accordingly. Very simple. Now we can just move on to the next question. You can also try it out with me if you want to. Okay guys, so we have solved this last question as well. In this we had to create our own DQ using either two vectors or two stacks. I went with two vectors, and I could have also used two stacks because my implementation, I basically kept the stack solution in mind as well while solving it. Although technically we don't even need two stacks or two vectors, you can just solve this using one vector, and the solution will be still be of the same time complexity. I will explain in a bit, but I still solved it using two vectors because that is what the question was asking me. So I created two vectors. Vector 1 will be the one that will be functioning on the original vector, you can kind of call it, which will be acting as the DQ itself. So for push underscore back, I just directly push back in vector 1. For pop back, I directly pop back from vector 1. Although I should do an empty check here, but anyways, moving on. And for push front, what I'm doing is, first of all, I'm clearing the second vector always, but although it will always be clear, but anyways, it doesn't matter. I'm clearing it. Then what I'm doing is I am popping the elements from the back of vector 1 and pushing it to vector 2, basically one by one. Just a second. Yeah, so basically what I'm doing is it reverses the current array and pushes it to the second vector. Then we add a new element in push back a new element in the first vector, and then we again pop all of the elements from the second vector one by one and push them in the original vector. So you get all of the elements in the original order, and a new element has been inserted in the front. Obviously with vectors you have an insert function to insert anywhere. You can also use that, but other than that you don't need two vectors anyways for this reversing thing. You can just reverse in the original vector. It makes your life much more simpler, but since it was asking me to solve it this way, of course I did. Then for popping from the front, I'm doing the same thing. I'm just clearing out the vector till there is only one element left, and then I'm popping that last element, and then I'm moving on with to the second step, which is popping back the elements from the second vector and putting them in the first one again. So the element in the front gets removed, and for printing the front, I'm just printing vector of 0. For back, just vector of back, and for size, vector size, and for empty, vector dot empty. Of course you can do it in other ways as well. I can say this was, oh yeah, by the way, one place where I was making a mistake is over here. I was doing note vector 1 dot size less than equal to 1, although I should have put a whole bracket in it. I was not, so it was interpreting only note of vector size, which is going to be true anyways, but okay, since vector size itself is true, and it will be returning a false, which is 0, which is greater than 1, which, or whatever, it just would not work. Let me show you. So yeah, since it is always greater than 0, you will get false in this, which is 0. Yeah, 0 less than equal to 1, condition is satisfied, but obviously not for this loop. It will always be satisfied technically. So anyways, we have solved all of the DQ questions that we could get our hands on over here. I don't want to take too long just solving DQ questions, although some of the questions were really good. For example, the sliding window question, and other one was this non-repeating character in stream. These two were really good questions. Other than that, the other questions were quite easy, but obviously we might have learned something new from each one by solving each one. So anyways, next we will be making a video. I will be making a video on something else from STL, practicing some few more questions from it. By the way, once I'm done with STL, I will start making videos on DSA. But in DSA as well, I will be moving in reverse order. I am not going to be like going from the scratch, showing everything from the scratch. First, I will be practicing like trees, graphs, and dynamic programming. Then, I will move on to other stuff like stack queues and other things. Only because I'm also practicing for placement, and those are like the more important things that are usually asked. So, yeah, see you guys next time. Have a good day. Keep practicing.
So please whatever. Please I want to reach 1 million likes. So please sarapakarai. Yes. Okay, thank you.